Welcome to Learning to Engineer. What are diodes? By this time you should be able to answer that, right? We saw two videos on the concepts of diodes. We even solved some basic problems in the previous videos. We need to step on and solve a little trickier problems to understand the concept better. Today we will be seeing three problems involving AC voltage application to diode circuit. In the previous three problems, we only saw the DC voltage application where we will decide whether the diode will be in off or on, and this is based on the forward bias and the reverse bias modes. Now we will use the same concept. On the top of it, we will understand what happens to the output voltage when we connect a diode in a forward bias and reverse bias. There are two different things. One, the output will be measured across the load resistor, and in the second configuration, output will be measured across the diode itself. In both these types of circuits, in both these types of AC circuits, we need to apply our thinking differently. When V0 is measured across the resistor, in this condition, the diode will be forward bias and be replaced as a short circuit. We are replacing this diode as a short circuit. So as a result, V0 will be 5 volt and the voltage across the diode is 0. Consider this condition. Here this diode will be reverse biased because a positive voltage is applied on the N terminal, so this will be reverse biased and hence this will not conduct. So now what we can do? We can replace this diode as a open circuit. Conduction does not happen and hence you can replace the diode as open circuit. What is V0 now? V0 is measured across the resistor. So V0 is 0 volt, but the entire 5 volt will appear across the open circuited terminals. In a series circuit, voltage divides, right? Consider that this is some element. Okay, this is open circuit. Consider that there is air. Okay, there is nothing here. If all the 5 volt appears across these two terminals, then this will be 0 volt. So when the diode is forward biased and you are measuring the voltage across the resistor, then you will get 5 volt and the voltage across the diode will be 0 because you are short circuiting it. When it is reverse biased, it will be open circuited and V0 when measured across the resistor will reach 0 volt and the diode's voltage will be 5 volt. These are the two things that you need to consider. Where is V0 measured? Whether is this across this resistor or is it across this diode? If it is across the diode, under reverse bias you will get voltage. If it is across the resistor, under forward bias you will get the voltage. Do remember these two key points. We saw these three problems in the previous videos. The first one was a very simple series circuit. Second one was a switching application where you had red and green LEDs and you decided the current path based on the on state of the diode. Next is a little trickier problem. This is actually a gate problem which had two parallel paths with two diodes. Okay, so now we will solve this problem. Here we are going to measure the output voltage across this resistor when a series diode is placed and Vi is a AC or this is a sinusoidal source. So in this case, what will be the output voltage across this diode? We are going to look at that. Okay, the peak voltage of this, let us say this is 5 volt. Okay, Vin is a sinusoidal wave, 5 volt is its peak value and the negative peak is minus 5 volt. Okay, the input voltage will increase from 0, it will reach a positive maximum, then it will reach 0 again, it will go to a negative maximum, then it will come to 0 position again. This is one cycle of a sinusoidal wave. So in the positive half cycle, what will happen? In the positive half cycle, let us say for example 1 volt is the voltage at that particular instant. Okay, when this is equal to plus 1 volt, this diode will be reverse biased and hence you can replace this as a open circuit. So there will be an open circuit in 1 volt, 2 volt, 3 volt, 4, 5, 6, 5, then again 4, 3, 2, 1. At all these positions, diode will be open circuited. So what will be the value of V0? V0 will be 0 up to this instant, post which the diode will be on. We had a diode which is connected in the reverse bias, right? So when a negative voltage is applied, let us say for example this is minus 1 volt and not plus 1 volt. Okay, when it is minus 1, minus 2, minus 3, this diode will be on. So when a diode is on, we can replace it as a short circuit. Okay, even though we are dealing with AC circuits, I am going to teach you as if this is a strain of DC voltages, because that is what is AC. It is going to be 0, 1, 2, 3, 4, 5. It will reach a positive maximum, then it will be 4, 3, 2, 1, 0. Okay, so I am going to tell you what will be the voltage at all these points. Okay, so when the diode is conducting, Vi will be let across this diode, this resistor. I am sorry. So here you will have a positive, I mean this is the positive terminal with respect to the V0. We are placing the red pointer of a multimeter at this end, and we are placing the black pointer at this end. Okay, so when we do that, we will be getting the negative half cycle appearing across R. This is the value of V0. Okay, this is called as a clipper. This is a positive clipper because it's going to clip off positive voltage. Now I'm going to change this a little bit. I'm going to put this diode in forward bias mode. Okay, so now what will be the value of V0? The diode will be conducting during the positive half cycle now, and it will be off during the negative half cycle. So when it is conducting, the positive half cycle voltage will appear across V0, and during negative half cycle it will be 0 volt. Okay, so this is how this diode will react, and this is called as a negative clipper. These are mainly used in circuits where you are filtering the input voltage. If you want only the positive voltage to reach your load, then you will use a positive clipper. If you want a negative voltage, you will use a negative clipper. This is a simple concept. Okay, now what I am going to do is I am going to introduce a small battery here. I am going to introduce a small battery with voltage, let us say 2 volt, and Vi's peak voltage is 5 volt. Let us say when Vi reaches 5 volt at maximum, 5 minus 2 is 3. So at the negative end, 3 volt will be the voltage, and at positive it will be less than 3 volt. This will actually be 0. So 3 is greater, which means the negative terminal potential is greater, and hence this diode will be off even though you are applying a voltage of 5 volt. Okay, because it will still be reverse biased. When will it be forward biased? Can you think that and give the answer? I'll look into this in a detailed manner. Okay, this is the sinusoidal input, and it starts from 0, 1, 2, 3, 4. It reaches a peak of 5, decreases to 0, then to minus 5, then again to 0. Okay, you understand this flow, and we will see it as a continuous stream of varying DC signals. Varying DC signals means it will be 1, then 2, then 3, then 4. So we are going to treat it with respect to the DC signals alone, so that we understand the diode operation in a better way. Okay, so when Vi is 0 volt, what will be the potential at this end? At this instant, what will happen? Vi is 0, so here it will be 0 volt, here also it will be 0 volt, diode will not be on. Yeah, this diode is going to be off. So when diode is off, V0 is also 0. When diode is off means you have an open circuit. When it is open circuit, V0 is 0. So Vi is a sinusoidal input whose value ranges from 0, then it goes from 0, 1, 2, 3, 4, then to 5, then 4, 3, 2, 1, again to 0, then it ranges from minus 1, minus 2, it goes in the negative part, then it reaches negative maximum minus 5, then again it comes 4, 3, 2, 1, and then 0. 0 minus 2, this will be minus 2 volt, and this will be 0 volt. The N terminal's potential is -2 and the P terminal is 0. So N terminal's potential is less than P terminal. So what will happen? Diode will be forward biased. You can replace the diode as a short. You can replace this diode as a short circuit. So what will be the voltage across V0? The voltage across V0 will be 0 minus 2 minus 2 volt. Okay. So now the voltage is -2 at this instant. At the second case, Vi is equal to 1 volt. Vi is equal to plus 1 volt. So it is 1 minus 2. Okay, because 1 is coming in this direction, 2 is opposing it. So it is 1 minus 2 minus 1. Okay, so it is -1 volt here and here it is 0. Again the N terminal's voltage is less than the P terminal's voltage. So what will happen? Diode will be on. It is forward biased. Okay, so this will be the voltage across V0. Now when this voltage is 2 volt and it is 2 minus 2, 0. When 2 volt is the voltage at the input, so it will be 2 minus 2, 0 volt, and here also it is 0 volt. So what will happen? V0 will be 0. Same for 3. Instead of 2, if it is 3 volt, it will be 3 minus 2, which is equal to plus 1. Here the voltage will be plus 1. Here what? Plus 1 volt. Okay. So the N terminal's voltage is becoming greater than P terminal. So the diode will be off. And you can replace it as an open circuit. So it will be 0 volt again. Again when it is 4 volt, it will be 4 minus 2, which is plus 2. N will be greater than P. So 2 volt will be greater than the P voltage, 0 volt. So again this will be off. Even at 5. 5 minus 2 is 3. 5 minus 2 will be 3. So again N voltage will be 3 volt, which is greater than P voltage. So diode will be off. V0 is 0 volt. When it is 4, that is also 0. When it is 3, it will be 0. 2, it will be 0. And when it is 1, what will happen? When this is again 1, this is how the diode was connected. Okay, so again when Vi is equal to plus 1, it will be 1 minus 2, 1 minus 2, which is equal to minus 1 volt. At this end, it will be minus 1 volt and it will be 0 volt here. So again, N voltage is becoming less than the P voltage. So what will happen? Diode will be on and hence you can replace it as a wire, as a short circuit. Okay, you are replacing this as a short circuit. What is V0? V0 will be minus 1. When it is 0, 0 minus 2 minus 2. So when it is minus 1, what is N voltage? Minus 1 minus 2, which is equal to minus 3. When it is 2, it will be minus 4, minus 2 minus 2 minus 4. So it will be minus 3 minus 2 minus 5. So again here it will be minus 6, minus 7. Okay. I'll draw all these for now. Up to this, I'll draw the waveform. So first what will be V0? It will be minus 2. I'm just putting these tabular column values into this graph. Okay. From Vi equal to 2 up to when Vi is equal to 2, that full cycle, which is from here to here, voltage will be 0. Okay, so when this is 2, it is 0. When it is plus 1, when Vi is equal to plus 1, okay, at the downward slope, what will be V0? Minus 1. Minus 1, then minus 2. Then when it is positive maximum of plus 5, it reaches minus 7. Okay, so from here it will reach minus 7. Minus 7 volt. Okay, so when the input voltage Vi is minus 4, what happens? When Vi, this is minus 4, minus 4 minus 2, it is minus 6. Okay, it will be minus 6. Minus 6 is where? It is here. Minus 6, then minus 3 minus 2, minus 5, minus 2 minus 2, minus 4, minus 1 minus 2, minus 3, and 0 minus 2 will be minus 2. Okay, so this will be the output waveform. Again, when you have the next cycle of Vi, what will happen? It will be 0. Again, this will be 0. 0 minus 2 will be minus 2. So from here, minus 2, minus 1 and 0. So this cycle, I'll draw it in a darker sheet, lighter sheet. Okay, it will start here. Okay, so this is how the waveform will look like. It will start from minus 2, then it will go to a negative maximum of minus 7, then it will stop at minus 2 for one cycle. Later, the next cycle starts from 0 to plus 2, the diode will be conducting, and hence you will get the output voltage like this. Okay, so this is how the diode will behave. Whenever you see diode in AC circuits and you are not very confident of this operation, put this tabular column. Okay, put Vi, put V naught. What are the 10 possible ways of Vi? You don't need to have every single value like this. I just told to spoon feed you enough at the first problem itself, so that in the next problem this much details is not necessary. Here I've done it from 0, 1, 2, 3. I've done every single step of the AC voltage. You don't have to do that. You just have to do 0, plus 2, plus 5, plus 2, 0. That's all. Okay, you don't have to go every single step, but to understand this in a better way, I drew the tabular column in every single step. Okay, now we will solve another problem. This is actually going to be a great problem. What is the value of V naught for this circuit? This is a DC circuit which has two diodes and two power supplies connected. Okay, so can you tell me which diode will be on, which will be off? This diode will be on because here the potential is 10 and here it's supposed to be less than 10 only, because you have a negative voltage. This is minus 15 volt. Okay, negative voltage. So here they are applying minus 15 volt, and even whatever be the voltage here, it is going to be less than 10 plus 10 volt only. So I'll assume that this is less than 10 volt. Okay, so what will be the diode's operation? Will it be forward biased or reverse biased? Yes, this will be forward biased. Okay, so you can replace this as a short circuit. Okay, so what about this diode? You are going to supply minus 15 volt and this is never going to be less than that. Okay, so this diode will be off. Off means open circuit. You can just remove that diode, that is called as off. Okay, so this will be open circuited. There will be no conduction that's happening because of this 15 volt. 10 volt will come. It will divide across two series resistors. This 10 kilo ohm is in series with this 10 kilo ohm. So the current will be the same. And what will happen to the voltage? Voltage will divide. V naught is equal to Vi into 10 kilo ohm divided by 10 kilo ohm plus 10 kilo ohm. So this is equal to 10 volt into 1 by 2. This will be 5 volt. Okay, this 10 volt is splitting as 5 volt and 5 volt. Okay, very simple problem. Okay, thanks for watching. Next we are going to next we are going to deal with VATs. I will be teaching the operations first, the characteristics. Later on we will move to the biasing modes and then the problems. Thanks for watching. Do subscribe to my channel so that you get a regular update once I publish my next video, and also ring the bell icon. There will be a notification on your mobile phone when I publish my next video. Thank you.